So I think I hope everybody has joined us here. I welcome our participants in the breakout session on contaminants, safety, and life cycle assessment. We will go through a number of quick presentations. As mentioned before, if you have not heard it, so Clara will organize the slideshow, but we can have some exceptions as just discussed with Sylvie. I want to start now and introduce Julia Tanzer. She is a colleague at Roman Management in Austria, and she will present the review of life cycle studies. So this is an evaluation, a review of existing life cycle studies on bio-based fertilizers. So Julia, the floor is yours, please.
Yeah, so hello and thank you, and hello also from me. As already said, I will present to you a review of life cycle studies on bio-based fertilizers that we recently did as part of the Lex for Bio project. Lex for Bio is a Horizon 2020 project where we look at how to optimize bio-based fertilizers along the whole value chain. And our review, as I said, was part of this. And we will later use it to develop a framework of criteria on how to do life cycle assessments on bio-based fertilizers to make them better comparable. Okay, please to the next slide. Thanks. So in total, we collected 123 life cycle assessment studies. And this is just to give you a short overview of what kind of studies that were. So for instance, most of them come from a waste management background, meaning that, for instance, they compared different treatment options of municipal organic waste. And therefore, municipal organic waste together with manure is also the feedstock that was most often analyzed in our studies. And regarding the treatments, we can see that anaerobic digestion and composting clearly are dominating in our sample. And overall, our assumption was confirmed that actually how these bio-based fertilizers are treated in the different studies are very variable, and often the assumptions are also not properly disclosed. But for now, we'll only show you one example on phosphorus fertilizers, and this is on the next slide, please. Yeah, actually, nowadays, most studies include the fertilizer field application, and they also use some kind of emission credits for the avoided mineral phosphorus fertilizer when substituting it with the bio-based one. But 1/3 of the studies do not properly define if field emissions are used or what kind of field emissions are used. And especially phosphorus emission are very often neglected and only included in 26% of the studies. And also regarding the substitution, almost half of the studies do not state at all what the substitution is based on. And another 30% use a simple 1-to-1 substitution, meaning 1 kilogram of phosphorus equals 1 kilogram of phosphorus, no matter in what form it is. And then even of the remaining 30%, 2/3 use a substitution rate of 100%, as shown in the figure on the right. And interestingly, there are some studies which are indicated with the dashed lines that have compared what effects the use of different substitution rates can have on the life cycle assessment results. And they found that actually this impacts can be significant. So clearly this will be one of the points where we will need to focus and look for better harmonization in our next step. Yeah, but for now, that's all from me, and thank you.
Okay, thank you. So our next speaker is Florian Gassauer from AREG Raumberg-Gumpenstein in Austria, and he will refer to circular agronomics. Florian, please go ahead. The floor is yours.
Thank you, Ludwig. Good day to you, ladies and gentlemen. My name is Florian Gassauer. And today I would like to give you a short overview of the Circular Agronomics project, and in particular a short glimpse on the goal and scope of our LCA calculations. So as you can see on the figure, Circular Agronomics consists of 6 case studies which are located in Spain, Germany, Austria, Italy, the Netherlands and the Czech Republic. And within Circular Agronomics, we defined 6 management and production strategies, which I put in the table below. And the 6 case studies yielded a total of 10 experiments, from which 7 experiments are suitable for LCA calculations based on their study design. Next slide, please. So onto the goal and scope of LCA. The goal is to calculate environmental impacts and resource uses of the different production systems within the 6 different strategies. And the scope is, of course, depending on the respective experiments. And I will give you an example of the scope on the next slide. We are doing LCIA with SALCA, which means Swiss Agricultural Life Cycle Assessment, which was invented by Gerard Gaillard and Thomas Nemecek from Agroscope in 2009. And on the table on the right side, you can see the 4 aggregated indicators which we are looking at within the LCIA. So for example, we have exergy, which comprises of non-renewable energy resources, or abiotic resource depletion, and so on. Then we of course have the global warming potential with a 100-year horizon. Then we are looking at eutrophication, the normalized eutrophication in terms of nitrogen and phosphor, of course. And we take a look at aquatic ecotoxicity. Next slide, please. So for example, experiment number 1 is on the nitrogen use efficiency of winter wheat and was conducted by the colleagues in Germany and the Czech Republic. And they are assessing the nutrient use efficiency of 3 different types of wheat genotypes with 5 different nitrogen application levels and under 2 different weather situations. On the right, you can see a figure with the system boundaries of that specific experiment. The functional unit would be 1 megagram or 1 ton of wheat grain with a specific moisture content. And the allocation, as you can see, is done separately. In Germany, we have no allocation because the byproduct, the straw, remains on the field. And in the Czech Republic, we are doing allocation based on monetary criteria because 50% of the straw is removed from the fields and sold. So much in a nutshell about goal and scope of LCA in circular agronomics. Thank you very much.
Okay, thanks a lot, Florian, about your approach to life cycle assessment. Our next speaker is Leo Breitfeld, and he's from 2B and will talk about the water to return project. So please, Leo, go ahead and present your results.
Okay, thank you for the invitation. You can hear me? Yes, okay, perfect. My name is Leo Breitfeld and I work for 2B. It's an environmental consultancy located in the northern part of Italy. And we are the LCA partner of the Water to Return project, which is coordinated by Biazul and which, by the way, also they have a presentation today in another session. Pilar Zapata from Biazul will give a general presentation of the project, while I would like to provide some insight on how life cycle assessment and risk assessment is applied to the Water to Return project. Starting point of the Water to Return project is wastewater from slaughterhouses, which in the traditional situation goes to sewage treatment, resulting in the emission of contaminants. With the Water to Return project, we aim to recover nutrients and produce fertilizers and biostimulants to generate reclaimed water and to produce energy in order to be self-sufficient. Water to return is a combination of technologies that consists of 4 treatment lines. So we have the water line, the sludge line, the energy line, and the alga line. Next slide, please. Yeah, thank you. So LCA is applied to the water to return technology according to the ISO standards, and the goal of the LCA is to evaluate the environmental performance of the water to return system. And the challenge is to make the LCA model of this circular system. In the inventory analysis, primary data have been collected by means of questionnaires of the 4 treatment lines, while data from the upstream and downstream processes are taken from the AgriInvent database. The impact assessment will be performed with the environmental footprint method, and we will also apply at least one alternative method. We're still working on the LCA of the whole system, so it's a bit too early to present results. In parallel to LCA, risk assessment is done in order to evaluate the occupational health and safety issues related to the water to return system. And the risk assessment will be based on the ISO 45000 on occupational health and safety management systems, where the data collection will be done by means of risk interviews and surveys. So in the first round of interviews, we will focus on the evaluation of hazards, pathways of exposure and risks, while in the second round, we will focus on prevention and mitigation. So risk will be evaluated semi-quantitatively by combining a risk matrix with the aim to provide recommendations to prevent and mitigate potential risks for workers. Well, the fact that LCA and risk assessment are done in parallel guarantees that both environmental impacts and safety issues can be optimized while looking at the same circular system. Next slide, please. So for any further information, please feel free to go to the references indicated on this slide. Thank you very much for your attention.
So thank you, Leo. You showed that also occupational safety and health could be included in the consideration. Our next speaker will be Natalie Litschko from Rhapsody. I hope we will get a nice Rhapsody in blue from you. Please go ahead, Natalie.
Hello. Good morning, everybody. I am Natalie Litschko from the Research Center of IMT Minalbi in France, and I will speak about phosphate-based materials for environmental remediation. Next slide, please. So first, I will present you different topics carried out in our research center. Our research corresponds to different technology readiness level. For example, from level 7 to 9, we carry out study about pollutant remediation in liquid phase or battery by lithium-ion battery. Also, we make research on phosphate for pollutant remediation in gas phase, also for catalysis, separation technology, as for example, dry reforming. And also, our research focus also to energy storage application of phosphate. Actually, it's necessary to develop phosphate-based materials for environmental remediation and energy storage. Next slide, please. So here I will present you 2 examples. First is heavy metal removal from urban and industrial wastewater treatment plant. We use a pilot in the wastewater treatment plant in which calcium phosphate were used. From this study, we can show calcium phosphate allowed to remove heavy metals up to 99%. And for some heavy metals, the removal was lower. In the second example is new research, where we see also the application, but also clean and regeneration of phosphate calcium. After they use, for example, in catalyst or as sorbent for gas or liquid remediation, we can calcinate or make a dissolution precipitation to obtain the metal phosphate powder used. After, we can active this phosphate gel, and we can use again this phosphate again as sorbent or catalyst. So as this, we close the loop of phosphate. Thank you.
Thank you, Nathalie. You remind us that phosphorus is not only used for fertilizing purposes.
Yes.
We have also and probably upcoming use in batteries, lithium iron phosphate batteries.
Yes.
And I thank you for this contribution, and go to our next speaker, that is Floris Schulters from Radius at Thomas More University. So please talk about circular Flanders.
Okay, thank you.
The floor is yours.
Yeah, thank you. So contrary to the others, I will talk more about contamination and safety issues. I won't talk about LCA. So we work with microalgae and insects, and one of our main objectives is to investigate the use of waste streams, streams that are often burned or put on the land. For example, liquid manure. We try to grow microalgae using liquid manure from chicken stables. Normally, this liquid manure, you have to spread it out on the land, on the aerial land, but some farmers, they don't have enough land, so they have problems and they have to pay to get rid of it. However, imagine you can grow microalgae on this wastewater and then use the microalgae as a feed additive for your chicken. Next slide, please. So you can go to a circular system. However, Europe, we still have some problems because Europe wants you to work in a circular way, and they provide you with money, and they write a lot of projects on this. However, the legislation is still problematic because prior to growing the microalgae, we are using liquid manure, so it's not allowed by law. You have a lot of microorganisms, you have potentially heavy metals, toxins, and the legislation here is very strict. Once it's waste, it stays waste, even if you use it to grow, for example, microalgae. So prior to growing microalgae, you have wastewater, manure. But what after you grow the microalgae? You remove a lot of the nitrogen and the phosphorus, yet it's still determined to be liquid manure. The microorganisms present, they are significantly below the threshold, and heavy metals in our study showed not to be a problem. So in the end, you have a waste product that's actually cleaner and clean enough, but it's still wastewater. So you have a problem there. Next slide, please. But the biggest problem is actually the microalgae. So you upvalue the wastewater because you use the wastewater to produce valuable biomass, microalgae. However, because the microalgae are grown in something that's determined wastewater, you can't really do much with them except burn them. However, our studies show that the microalgae are similar to microalgae grown in normal water. The parameters, quality and safety, you can test them and they seem to be fine. However, there is absolutely no legislation. So we are able to upvalue a waste product, but in the end, the upvalue product you have by legislation is still defined as waste. So we need better legislation in order to really advance this type of studies. You can collect phosphor, nitrogen from waste products, but in the end, if you can't use them, it still stays waste. And that's my point here, and that's what I wanted to talk about. So thank you for your attention.
Thank you, Floris. I'm not sure if you are aware that ESPP has just redacted and sent a paper exactly addressing your product, that we are your problem, that we are missing legislation for algae that is grown in wastewater, which is a reasonable approach because wastewater contains the nutrients and the algae directly use them. So we are aware of this. We have addressed it, and the Commission is also preparing criteria for end of waste for different material flows. This is underway, and more details will be available during or after summer. So please watch our publications and join them if possible. Thank you very much.
Thank you.
Our next speaker is Maria Teresa Morera from University of Santiago de Compostela, and she will talk about Run for Life and LCAs in different sites.
Hello, everyone. I would present here just a short overview of the Run for Life project. In fact, it combines two topics. One is the centralized wastewater treatment, and for this we consider different demo sites and different conditions, different residential conditions, starting from small communities. That is the case that I'm going to present today, SNIC, that goes up close to 100 inhabitants, up to a residential area, rather residential and new construction area in Helsingborg. We also consider the possibility of including this decentralized system in office buildings. That is the case in Vigo in Spain. So we apply the methodology of LCA, trying to identify what are the impacts for decentralized treatment. In this case, I'm going to present here the simplest case scenario, that is SNIC. And you will see that we combine here two options. One is the use of ultra-low flush vacuum toilets. So instead of using the conventional toilets that consumes around 7 to 8 liters per flush, we are introducing this type of toilets that reduce the consumption of water by 90%. Apart from that, when we have this black water concentrated, we will have a higher yield in biogas production. For this, we consider anaerobic digestion working in thermophilic conditions. So with the biogas, it's possible to produce heat that will be recovered to maintain the temperature of the reactor, and also the excess will be used by the community. In the D state, we will have the fertilizers. We will have two types of fertilizers, solid and liquid stream. Next slide, please. And the first question is, what is the environmental profile of our decentralized treatment in comparison with the conventional options? So when we have the water sent to a centralized facility. In fact, when we see the results, not everything is so good for the decentralized system. You will see that in terms of global warming potential and terrestrial ecotoxicity, we will have larger impacts in the case of decentralized. But it happens that for the rest of the impact categories that we consider, the decentralized systems performs much better. And the reason for that is that we have to take into account that the small facility, we will have the consumption of energy that accounts in the global warming potential and the maintenance of the vacuum conditions, not only the use for the toilets, but also all the pipes. And next slide. But when we open the scope to urban farming, that is also the objective of Run for Life. What happens with the biofertilizer that we obtain? We were told by the other partners that these biofertilizer are safe to be used for agriculture. So when we have this urban farming close to the houses, when we have small plots of land, when we can cultivate, let's say, carrots, beans, tomatoes, something like this type of agriculture activities that goes beyond the production of foods, that also involves the commitment of the community into social activities, also for leisure options. And you will see that including the urban farming, the environmental impacts decrease a lot. So we will have here that in all impact categories, only except by acidification, the environmental impact is lower when we combine the centralized treatment of wastewater, but also the urban farming. The reason for the acidification is related to the lower uptake of nutrients and the emissions, and the emissions associated with the use of biofertilizers. So we consider different uptakes ratios between mineral and biofertilizers, but also the emissions are different. So these are also something that we have to be aware of. But in general, the message is when we have the centralized wastewater treatment, we should recover resources because that is the idea, and the results support lower environmental impacts. Thank you very much.
Thank you very much for this nice presentation, also on a different approach from urban agriculture and urban recovery. Our next and last speaker for this session is Rahul Ravi, and he will talk about Nutri2Cycle, and he is from Ghent University. So please, Rahul, the floor is yours.
Hi, thanks Ludwig. Hi everyone, my name is Rahul, and yeah, I'm at Kent University, and what we're working on in the Nutri2Cycle project is we're just looking at struvite recovery. We're taking an illustration of a pea fertilizer, and we're focusing on two aspects. First is just to see whether or not struvite recovery makes sense, and the second aspect is to compare the future consequences of wastewater sludge end use. So basically, we split it up into Model 1 and Model 2. The first one, we take a retrospective approach where we look at the current wastewater treatment plant in Leuven, which is run by Aquafin, and they use the Neurassist technology. And we compare it to a time in the past where struvite recovery wasn't implemented. And then Model 2 looks at the future consequence of wastewater sludge end use. So currently, the practice is to send part of the wastewater sludge to co-incineration plants and some of it to be valorized at the cement kilns, whereas in the future, the idea is to completely mono-incinerate all the sludge. So we just wanted to compare what it looks like. So could you move on to the next slide? Yeah, so as Sylvie mentioned earlier, our approach is also along similar lines. We didn't want to go into the whole debate of the product versus waste perspective. We just looked at the ISO guidelines and went with system expansion, which is the most recommended step. So basically, the first one is the status quo, which is the post Neurassist after implementing the Neurassist technology. So the function of a wastewater treatment plant is to treat wastewater in this case, and you also get a useful product in terms of struvite. And when you compare it before Neurassist was implemented, essentially the function of the wastewater treatment plant was just to treat the wastewater. So in order to balance our functional unit, we expand our system boundaries and also include synthetic pea fertilizer. And for this, we used the updated inventory, which Ludwig was also part of from the German Environmental Agency report. And we looked at the TSP and SSP, which was brought into Europe from Africa and Israel, respectively. So this is our approach to Model 1. And if you could move on to the next slide. Yeah, so Model 2 looks at consequences of wastewater sludge end use. We use a prospective approach. So currently, like I said, around 1/3 of the wastewater sludge is dewatered and dried and subsequently valorized in the cement industry, whereas the remaining 2/3 is dewatered and sent to co-incineration facilities. So the idea of Aquafin is by 2026 is to completely mono-incinerate all the sludge. And just to make it interesting, we looked at like other studies, which also said there's a possibility to process the ash and make it more available for plants. So we included that as an additional step and compared basically the status quo and the mono incineration and ash processing. And just for argument's sake, Flanders doesn't allow land application of wastewater sludge, whereas Wallonia does. So we just wanted to see, okay, hypothetically, what would be the environmental impacts if you indeed go for land application. So we also compared that as one of our scenarios. So yeah, that's it from me, and thanks a lot.
Okay, thank you very much. I think this was the last presentation for this session, if my program version is correct that I have. Clara, do you have something else, or do you agree?
No, this is the last one.
Okay, so thank you all for your very precise, very concise and meaningful presentations. At present, so I think we open the floor now for a discussion and for some question and answers. And I have here one question from Jean-Romain Bautista well, I think it's for Maria Teresa. Could you detail your allocation rules for the Run for Life project?
Yes, of course. Sorry. What we have here is two systems combined. So what we have is the wastewater treatment and also the application of the biofertilizers into the land for the agriculture activities. So depending on the approach, on the scope that we consider, we have different allocation rules. For example, in the first case, when we consider the centralized scenario, only the treatment of good water, it is true that we allocated the impacts of the treated effluent. So that was comparable, more or less. And we also consider the avoided heat, considering the valorization of the biogas produced. But when we have the scope, the wider scope, and we applied in the agriculture, the biofertilizers that we have, we consider also that we need to produce an equivalent amount of nitrogen, phosphorus, and potassium for the cultures or for the crops. And in this case, we allocate the impacts not only to the heat, but also to the quantities and the percentage of the different nutrients present in the biofertilizers in the different streams. So that was the comparison when we have only the treatment and when we have the treatment with the urban farming. Allocation rules may change.
Thank you very much. I don't see any other questions. So please, if you have questions, please just raise your hands, and Clara will give you the floor. In the meantime, I have one question to Rahul. You had in your slide number 2, you had different values for different countries in terms of beneficiation of rock phosphate, if I understood it correctly. How did you come to these different values? How did you calculate them? Because they were quite different. I think the beneficiation methods are rather similar everywhere, aren't they?
That was actually from the UBA report, if I can remember right. I think these are the market mixes for Germany, and it is mostly gotten from Africa, right? So we sort of adopted that those values for our PMix.
Okay, thank you. Clara, you shared a link Sorry, what?
Hello, can you hear me?
Yes, I can.
Yes,
I can.
I shared the link of the Jamboard to all participants in the chat if you want to use it, okay?
Sorry, could you repeat? And
I
speak
shared
up
the link for the Jamboard in the chat.
Yeah.
Okay?
Okay.
To all participants.
Okay.
Okay.
And participants can now please explain what participants can do.
Yes, they can access to this link.
Yeah.
If they want.
Yeah, and they should write their comments there, or?
Yes.
Okay.
But they can
Okay,
use the chat for the questions.
So this is okay. Okay, perfect.
How they prefer.
Thank you.
You're welcome.
One question from me to Natalie. Since you mentioned the use of phosphorus in the lithium iron batteries, did you do a mass flow or a forecast analysis regarding the let's say potential or forecasted use of phosphorus and particularly of these types of batteries that use phosphorus? Natalie, did you hear me? No, apparently not. I don't see her anymore. Okay. Then maybe a question to all of you, and I hope you, to get some feedback and some answers. What you have seen from the presentations, we have really different approaches to life cycle assessments, but of course also to related analytical processes. How do you see the difficulty that, for example, policymakers or other scientists may have when they should compare different processes with different life cycle assessments coming from different projects? Do you see a chance how this can be made or be more homogenized in a way that an observer or a stakeholder could use these assessments for a personal judgment? So how is it? Any comments?
Okay, if I can intervene, I would say that it is not so easy when we really look for a competitive process to the existing one, that is the production of mineral fertilizers. One of the main concerns that stakeholders tell us is that they don't think that, for example, in the case of the centralized system, they don't think that we can be competitive in the sense that we cannot provide sufficient amounts of biofertilizers, and also how they can be accepted by consumers. So I think that there is also some implications regarding the regulations using these biofertilizers, because we have to take into account that they need to comply with the level of minerals or with the level of metals that are added to the soil. So the generation of leachates from these metals is something to be taken into account, but also not only the metals, but the pharmaceuticals, in fact. So this is something that it has to be evaluated in LCA also, when we have this detailed composition of the biofertilizers, not only the nitrogen, phosphorus, etc., not only the nutrients, but also what are the implications of using this type of biofertilizers in terms of the complete compositions that they have, and also the acceptance, the social acceptance, and if they can be competitive with, to some extent, with the mineral fertilizers. In our case, I have to say that it makes no sense to identify the production of biofertilizers as a competitive, as a competition with the existing ones in the market. But imagine when you have these areas that you can add the biofertilizers for parks, green areas, or for even horticulture. So this is something that has a possibility. And I think that in this case, maybe we can start with these objectives instead of being competitors of the existing market.
Mm-hmm. Yeah, thank you. I think this is a very, very meaningful approach, not to see the products from primary resources and secondary resources as direct competitors. In the meantime, we have also discussion in the chat. Floris had a question to Rahul, so maybe Floris, you speak up and you put the discussion public for the whole audience.
Yeah, I was wondering, at a certain moment he mentioned something about the difference between the French part and the Flemish part in Belgium in terms of yeah, using the land to apply the, I think it was the sewage sludge or something. Yeah, so do you have more information about the details? Because even in the Flemish part, they do use the land to, for example, use to get rid of the, what I was explaining, the wastewater from the chicken or from a cow farmer. So is there a specific difference between sewage sludge and then the agriculture sludge?
Indeed. So wastewater sludge, they are concerned about organic pollutants and heavy metals. So yeah, Belgium has this weird legislation, right? Wallonia has different, and Flanders and the Brussels region. So Sylvie can correct me if I'm wrong, but from what I saw, around 50% of the sewage sludge produced in Wallonia is allowed to be land applied. Whereas in Flanders, they make it clear that it has to be incinerated.
Yes, in Wallonia, if I can answer, there is a difference also between the small scale wastewater treatment plant and the large scale, because you have the problem that the large scale wastewater treatment plant are usually situated in a part that can receive also industrial wastewater. So they have to dewater the sludge, do analysis to check if there is no pollutant or contaminant coming from a problem in the industries, and then only after that the farmer can apply them into the field. So you have a large amount of dried sludge or dewater sludge that stays on the road near the plants, and if the analyses are bad, they have to go back and get back the sludge. So for the large wastewater treatment plant, usually there is much less or there is less direct application on the field, but a part goes to composting, where the treatment of the sludge can sanitize in some way the sludge, and there is also a dilution of the pollutant with the other biomass that is composted.
But even after this composting or fermentation, can they still use it? Because I know in Flemish part, if you have a fermentation unit, if you put in sewage sludge or similar type of sludge, you are actually contaminating your fermenter, and the legislation also changes, and it becomes even more difficult to apply to the land. So I'm not sure how it works in the French part.
There is also the regulation, but if the sludge is clean after analysis, they can apply it.
Ah, okay.
So okay, in some way it's maybe the difference.
Yeah, it's very difficult to follow the legislation.
Yeah, and it looked like we had a meeting with some German partners in the Phosphor project this week, and it looks like that even in Germany, the legislation is changing about the authorization of struvite. And now it should be not allowed anymore to put the struvite in the field. And there is also legislation that is changing about the pea containing ashes after incineration. It's moving all the time. It's very difficult to follow. It's a real problem for the people that try to recover the pea from different waste.
Okay, thank you.
I hope it helps.
Yeah, thank you.
Okay, thank you very much. When I go back to Julia's presentation, we have seen that many LCAs with regard to bio-based fertilizers do not differentiate between the nutrient use efficiency of mineral or synthetic products and bio-based products, and actually there can be huge differences. What do you think of that? And what I perceive from the different studies is that also the knowledge, or let's say a common knowledge, a shared knowledge between stakeholders is not there. So the efficiency estimations range from 20% to 100%, depending if somebody regards the present year or then 100-year availability for phosphorus, for example. So is there any comment, any input on that? I think this is one of the main differences or difficulties to make LCAs and comparative considerations available and understandable. Yeah. No comment. So well, I think this is so I'm alone with my statement, but I think this needs to be considered and needs to be further investigated. And if possible, we need to find, or we should try to find a common position where we say, okay, we consider emissions from manure like this, and emissions and use efficiency, because if you have lost half of your nutrients before you apply it to soil, use efficiency cannot be very high anymore. So I think this is, and particularly in regard to the farm to fork strategy, this is an important aspect that needs to get more attention. So I think common understanding for nutrient use efficiency of bio-based fertilizers could be one of the areas to particularly focus during the next research projects, and particularly during life cycle assessments. And of course, also the overall functional units, allocations, should also be somehow harmonized in a way that LCAs can be made comparable for non-researchers. I think this is important, and also, of course, the different input parameters should be transparent, that somebody that reads the LCA can have a judgment. And if there are no further comments, questions, I would tend to close the session. Do everybody agree?
Hello, I would like to remind you that you have time for lunch until 2 p.m. Okay, yeah. You can leave the session open, or you can close and come back at 2 to the main session by using the same link, as you prefer. Okay, thank you very much. I also have to thank now Aurora. She is the rapporteur for our session, and she will come back and give a summary during the afternoon plenary session. And I also thank Clara for managing this session. Thank you to you. Thank you all. Thank you all.
Thank you, Ludwig, and to the speakers for the excellent moderation.
Yeah. So thank you all for attending, and see you in the afternoon at 2 o'clock in the main session. Thank you very much.